Hello, my name is Annie, and I believe that you should all learn math. Specifically, trigonometry. Annie. Trigonometry. So, we should learn some trigonometry, right? So here we go. We are on 16.3. And, oh look, I can identify how f of x plus h and f of x plus k will shift the graph. Have we ever seen that before? Yes. Yes, we have. So, it's all the same as we've learned with all of our other functions, so hopefully this section won't be too bad. What is our spark on learning? So the ocean rises and falls over the course of the day. High tide, low tide, things like that. And let's see here, every 12 hours and 25 minutes, or approximately 12.42 hours. So this is what high tide looks like. This is what low tide looks like. So it goes back and forth, kind of like a trig function, right? So in this case, we could model the depth of the water, or at least in comparison to this little building right here. That's what they're doing, by using a cosine function. So again, one of the joys of these trig functions, it's not all about triangles. Sometimes it's about those graphs, and since they go up and down, you can use them to describe a lot of different types of cycles in the real world. So let's get right to it. Be translating or moving the graphs of our trigonometric functions. So as a friendly reminder, so we've got our A. So like if we're looking at something like this, we've got our A that represents our amplitude, which also indicates a vertical stretch. We've got our B, or 1 over B, which indicates a horizontal stretch or compression, depending. So now we throw in one more component, and we've got the H and the K. So the good part about this is nothing really changes from the last part. This H represents a left to right shift. Notice that there's a negative sign here, so the signs are still going to switch. And this K represents an up and down translation, or moving the graph up or down, or vertically. And that's true for both sine, cosine, and tangent. So the good news is that this one rule that works for absolute values, functions, whatever, also works for trig functions. So let's see how we do. It says graph at least one cycle of the function f of x equals 1/2 cosine of 4 times x minus pi over 4, close parenthesis. And when it's written like this, know that all of this is insinuated to be inside of the cosine function. Once you get out here to this plus 3, it is outside of the cosine function. So definitely double check on your calculators as you're entering this stuff in, if and when you need to enter this in. I would, if I was entering it in my calculator, just to be sure, I would put my whole trig function in parentheses. So I would do something like this when I enter it in, just to make sure that my calculator is doing what I want it to do. But I digress. So on number 1 here, it says graph at least one cycle, use the parameters, blah, blah, blah. So in the equation for f, a is our amplitude, is 1/2. So the full amplitude is 1/2. That's a vertical compression. Amplitude is 1/2. And the period is 2 pi times 1/4, which equals 2 pi. And we got that because our b here equals 1/4. So remember the generic graph, or the generic function is, for cosine is, oh, come on, pencil, a cosine 1/b x, and then we're adding h and k, but we'll get to that. So let's see here. So that b is 1/4, because again, we've got 1/b equals 4, so therefore b would equal 1/4. So I just kind of wanted to work that out visually so that we're all kind of tracking on the same thing. So our a is 1/2, our b is 1/4. Whoop! We're just going to zoom in real quick. And while I have the function in front of me, we're just going to write down everything that we know. Our h is pi/4. But Mr. Lin, it says negative pi/4. Remember, our generic equation also has a negative sign, so this is always going to switch signs. Don't forget that. And then our k is 3. So I'm just writing all that down because I have a feeling we're going to answer some questions about it. So y is 1/4 used to determine the period of f of x. Match the choices. Oh, let's see here. In general, the period of the cosine function is 2 pi times b. In the given function, the value of 1/b is 4. This is things we've already done. Therefore, b equals 1/4. So the period is 2 pi times 1/4, which equals pi/2. Yay. What is the amplitude of the period? So this should all be review at this point. We've done this in our previous module. The amplitude indicated by the graph of f is compressed vertically by a factor of 2. The period indicates that the graph of f is that's the period. So our b is also compressed horizontally by 2, or by 1/2. The period indicates that the graph of f is compressed horizontally. By a factor of 4, because it's 1/4. My bad. So here's where we get into kind of the new stuff. So remember, it's talking about a midline here. So remember our general trig function looks like that. It's got that midline that goes through the center, and then we measure our amplitude from that midline. Typically, up until this point, it has always been at y equals 0. No longer. Since our k equals 3, the midline of a trigonometric function has the equation y equals k. So our midline is now going to be y equals 3 for this function. So like if I were to put this onto a coordinate plane, 1, 2, 3. Now, of course, that's completely and entirely not to scale, but whatever. Let's see here. So the midline for f is at y equals 3. while not part of the graph, the midline acts as a guide when drawing the graph. So you don't have to draw the midline in there, but it's really good to know where it is. So how can you use the midline and the amplitude of f to find the y-coordinates of the maximum and minimum points of the function? Select the correct justification. So you start with a midline value 3 and add and subtract the amplitude of 1/2 to get maximum and minimum y values. I'll agree with that. Start with the midline value at 3 and multiply? No. Start with midline value at 3 and add and subtract half of the amplitude? No. So it is the full amplitude. The amplitude is defined by the distance from that midline to the maximum or minimum. So the value of h here, so this one, for f of x is pi over 4. So the graph is shifted pi over 4 units right when compared to the graph of the parent function. This is nothing new. This would be the same thing as if we were doing any of the other functions that we've used before. So then they're talking about the parent, for the parent cosine function, 0, 1 is the maximum point, and pi, -1 is the minimum point. So you can use these values to then find the new maximum and minimums that they're referring to, or the reference points, and that's just applying these changes to it. So like the 0, 1 is going to be pi over 4, and where do they get 7 over 2? So the y, so you start at the midline, which is at 3, and then you add 1/2 to it, and then they just convert it into a fraction. So you can use these parameters to then find the max and minimums. Cool. All right. How are the parameters of f used to determine the maximum and minimum points? We just talked over all of that. I'm not going to go through that. I think that's just what we talked about. Here's our graph. Yay! So again, here we've got a midpoint, or midline at 3, and then we only have 1/2 of the amplitude, so check the scale. And it is a cosine, but it shifted to the right, right? Yeah. There's your graph. So how can the maximum and minimum points you have found and the period of f be used to find some of the points where the graph of f crosses the midline? Recognize that all the points on the midline have the same y value of 3. That's true. Oh, these are the steps that you should be thinking about. Got it. So it says recognize that all the points on the midline have the same y value. In this case, that y equals 3. Note that there is one point on the midline between the maximum and minimum values, and there is a simple way to find its x value. Average the x values of the maximum and the subsequent minimum to find the point. So because this graph is regular, you can then just find halfway in between these 2 points, and that's going to be where it crosses the midline. And then define an infinite number of points, add integer multiples of the period. In this case, the period is 2 pi times 1/4, which is pi over 2. And so then every pi over 2 period, you're going to get a, the graphs are going to cross the midline. So since the minimum value of the function is 2.5, there are no x-intercepts when x equals 0, f of blah, 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 blah. So you can go both ways, right? You can take an equation, use the parameters to make a graph, or you can take a graph, use the parameters to make an equation. So let's do it. Create general trigonometric functions from a graph. So we can look at the key features of this graph to figure out what the equation is going to be. So note up here it says the halfway points are plotted on the tangent graph along with points on the midline. That's useful to know. So based on looking at this, we can already see at this point and this point, so that's probably our midline right there, right? Boop, 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 boop. At y equals -2. So, because we know the midline, that gives us our k. So that also equals our k. Look at that. We're well on our way. What type of transformation is associated with the midline? That's going up or down. So we would call that a vertical translation 2 units down. So the period is 4 pi. And the way they found that, so let's draw in some asymptotes here. And then my lines aren't very straight, but whatever. So this asymptote looks like it's right at pi. And then this next one, let's see here, which direction do I want to go? Would be at, what is that going to be? So this one over here that I drew would be at negative 3 pi? Yeah, I want to say negative 3 pi. Let's see what the book tells us. The period is 4 pi, which makes sense because I was talking, it went from pi to negative 3 pi. So pi minus negative 3 pi would be 4 pi. So we agree on that one. So pi times b equals 4 pi, b equals 4. So from the asymptotes, we can figure out what the period is, which is how we can figure out what our b is. How do you know the period is 4 pi? Select all that apply. Oh, that's clever. To find the period, you can pick any point on the graph. So they just picked points that they knew as opposed to me, who was kind of sort of guessing. Graph intersects the x-axis at negative 2 pi and 2 pi. So the period is the distance between them, which is 4 pi. I'll give them that. That makes way more sense than I did. It takes 4 pi units for one cycle to complete. Yeah. So a comparison of the midline location to the halfway points shown shows that A equals -2. So we've got our midline, and how did they get -2 for our amplitude? So I can see where they got 2. Because our normal graph, so our parent function, the 2 reference points would be right up there, 1 unit up or down. In this case, it got stretched to an additional unit, so I get the 2 part. Where did they get the negative from? That's what we got to figure out. Oh, wait. So this is a tangent graph, but it's decreasing. A parent function tangent is increasing. So it got flipped, and you would do that by using the A. So, okay, I'll agree to that. How is the value of A determined, and what types of transformation occurs in the parent function? The magnitude of A can be determined by finding the, let's hear, sum or difference of the y coordinates. And we'll go difference, because you could just subtract the two. But since the graph function is decreasing function, while the parent function is an increasing function, the graph must have undergone a reflection and vertical stretch with magnitude of 2, and A must be negative. Again, we kind of talked through all those. So the parent function has its midline at y equals 0, and one branch of the graph crosses the midline at the origin. The graph shown here has a midline at y equals -2, so you already know that the points are shifted 2 units down. Focus on the point on the midline at -pi, -2. This point shows that the shift of pi units to the left, indicating that h equals -pi. So let's look at that graph again. So again, we've got our normal graph, or our parent function. So I'm going to do the parent reflected function. So basically, if it was like a negative tangent, would look something like this. So that point right there went down 2 units from our k, but it also went over -pi units. So our h would have to be -pi. So especially with some of these trig functions, it's probably pretty important to know what the parent function looks like so that you can kind of make these judgments as you go. So we get rid of that. Come back down. H is -pi. And then from that, we can shove it all together, and we have our formula right here. That's just plugging it all back in, right? Same thing, except this time we're going to use a sine function. So I mentioned earlier that it's really important to kind of know what the parent functions look like, especially as we're dealing with translations and things like that. I'm not going to give that to you, but you have a calculator, so you can always use it. So worst case scenario, you can always go to your y equals, stick in sine of x. When you deal with your window, that's weird. So note that I am in degrees. So if I want to see a full range of the trig function, you're going to need something, I don't know if this is going to work or not, but you're going to need something like that. And remember your y minimum. So your trig functions go from -1 to 1. So here is your sine wave. Notice that it does go through the origin, and that's probably going to come in handy later on. Good way to check yourself. Just make sure, whether you're in degrees or radians, make sure you do it right. Anyway, so here we go. So we've got our sine wave. Assuming that this might be the midpoint, if we go up 1, 2, 3, down 1, 2, 3, cool. So the amplitude is 3. I went both sides, so I want to make sure that that was actually the midpoint. Who knows? Maybe it's not. I don't know. So our amplitude is 3. The amplitude is the difference between maximum and minimum. Yeah. So you could also take this number and find the difference from that number. So in this case, you could do like 8 minus 2 divided by 2. So the amplitude is half of the difference. So the midline of the graph is y equals 5. That's kind of what we were looking at right there. So I guess we start writing this down. So y equals 5, which equals, if it moved up, that's k, right? And then our amplitude equals 3. So our k is also equal to 5. That's what I wrote down up here. Which of the following are true statements that help to determine that b is equal to 4 divided by pi? So remember, b is about our period. And so that's going from like here to there. So the distance between subsequent maximum points is 8 units. I'll agree to that. We got a positive 6 over here, negative 2. 6 minus negative 2 is 8. And we know that the period is 2 pi times 4. I'm sorry, 2 pi times b, which has to equal 8. And then we do algebra. So just in case you weren't tracking, so we know that the period is 2 pi times b, and we found that the full period is equal to 8. So then we just do some algebra. B equals 8 divided by 2 pi, which equals 4 over pi. So I just want to make sure that was clear for everyone. So B equals pi over 4. So now we just need what? H, and then we're kind of good to go. So again, I intentionally reminded you to look at the parent function beforehand. So it goes through the origin here. So we already know that k, it moves up 5 units. 1, 2, 3, 4, 5. So that, and it does not have a horizontal shift at all. So that means that our h is equal to 0. Wait, what? To determine the value of h, examine where the point 0, 0 of the parent function sign shifted. Since k equals 5, point shifted up 5 units. On the parent graph, point 0, 0 is part of the curve that is rising. Oh, I made a boo-boo. So look to the right. Oh, yeah, I totally messed that up. They got me. So goes to the origin, and it's increasing. Goes to the origin, and is decreasing. So it moved to the right, and you can even do to the left. It technically doesn't matter. But it moved to the right enough to where a full half period. So it moved all the way over that way. Man, shame on me. So then it moved to the right. Our period is 8. So it moved to the right 4. I'm going to catch somebody doing that on the test. I can tell you right now, someone's going to miss that. So h equals 4. Can h have been a different value? So I mentioned this earlier. With sine functions and cosine functions, if you move a certain amount, it doesn't matter if you go left and right. So you can find a negative h value that will give you this graph. because of how the sine functions work. So one possible sine function is, once we have all the parameters, we plug them in. These examples in class are going to be so much fun. We got to end it out on a real world scenario, right? So, trigonometric models for real world phenomena. For example, how to deal with an overbearing German Shepherd. Go away, Rudy. So, what do we got? Each gondola on a Ferris wheel travels at the same circular path during the ride. Suppose the height h in feet of the pivot point of the gondola above the ground is modeled by the function given. There it is. So why would a cosine function work for this? So if you think about it, the height, if you start here, would start at, kind of like 0. And then as it goes up, it increases. And then it hits a maximum. And then it decreases. And then it increases. And then it decreases. So that's why these sine and cosine functions are very handy. So identify the key parameters of the function. So they give us all of the important information. So our period, 2 pi times 60 over pi equals 120. So our b, remember our b is right there. Our b is right here, but remember it's always 1 over b. Whoops, that says 1 over 2. 1 over b, and so we have to reciprocal that. So our b is actually 60 over pi. So then our midline is h of t equals 37. Let me fix my settings real quick. Our amplitude is 30. They, of course, have a negative 30, which gives us, and then they have a maximum and minimum. So, looks like we've got a couple questions for it. Didn't tell us to solve anything, which makes me really sad, but I'm sure we'll have our opportunity. So, comparing the given function with the general form of the cosine parent function, one notes that, and I don't remember, so just because, let's remind ourselves what the cosine looks like. So note here at the origin it starts up here at 1 and then goes down and then goes back up. So that's what I'm going to kind of keep in mind as we go through the rest of these. So comparing the given function to the general form of the cosine parent function, one notes that 1 over b is equal to pi over 60. So b equals 60 over pi. We talked about that because it's a reciprocal. In general, the period of a cosine function is given by 2 pi times b. So the period of this function is 2 pi times 60 over pi. Yay. How are the maximum and minimum values found? So up here we have our midline, we have our amplitude. So our maximum is going to be our midline plus our amplitude. Our minimum is going to be our midline minus our amplitude. So let's see here. The maximum and minimum are found by adding and subtracting the amplitude from the t-axis. If by t-axis they're referring to the midline, that's probably what they're talking about. But let's just read the rest of them. The maximum and minimum are found by adding and subtracting the amplitude from the constant given an equation? No. Maximum and minimum are found by adding and subtracting the period from the constant? No. maximum and minimum are found by multiplying? No. What? So the midline, the maximum and minimum are found by adding and subtracting the amplitude from the t-axis. Oh, so the t-axis would be the x-axis in this case. So let's try again. From the constant, that's why. So the constant is the same, it's the k, which then gives us our midline. So our midline is 37, which is also the constant that they give. Okay, good job, book. That was a good connection there. Determine the points where the graph intersects the midline. H of t equals 37 when cosine. So if we write this equation, I'm going to write it on the screen so we don't have to keep going up and down. So h of t equals negative 30 cosine pi over 60 t plus 37. Determine the points where the graph intersects the midline. So the midline is at 37. So if we look at our equation here, h of t will equal 37 when this equals 0, which also means, which will equal 0 when this equals 0. Oh, hang on. Probably should include the variable there. So when cosine of pi over 60t equals 0, the value of the cosine function is 0. So then we've got a list of things, and at this point you would just, you can either look at your unit circle or look at your graph and then just figure out if you're looking at the graph, look at it whenever it crosses the x-axis, or if you look at the unit circle, you can figure out every time cosine hits 0, when this part of it hits that, then cosine equals 0. So either one of those works. I'm sure that we will go over some of those in class. So they did when pi over 60 times t equals pi over 2, because that's when cosine hits 0. So then they did some algebra, got t equals 0. Then they did the other one, if you keep on going. So that's like what? Whatever 180 plus 90 is. So like 270 degrees or negative 90 degrees. So the graph intersects the midline twice during one cycle at the points 30, 37, and 90, 37. 90? I thought they got 60. That might be a typo. Anyway, so what does one cycle of the graph represent in the context of the situation? So this is kind of an important part to understand of like, okay, we can do all this math, we can find the answer, but what does the answer actually mean? So this is a good question. So one cycle represents the, let's see here. So we're talking about from here to there. Height above the ground of the gondola's pivot point during one rotation of the Ferris wheel. So again, we just kind of thought through everything. Determine the maximum and minimum points of the graph. Didn't we do that already up here? The maximum. So the cycle begins with the gondola resting nearest the ground. So the minimum point is 0.7. A second occurs at the end of the cycle at, okay, the only maximum point occurs midway through the cycle at 60.67. It's the same thing that we got up here? Yeah. So we figured out, or they gave us 67, and then you just figure out when it hit 67. That was weird. The pivot point comes back down to a height of the axle, 37. Okay. So this is just interpreting all the stuff that we figured out. So the graph of the model looks like this. I'll erase mine. So you start here at, whatever the starting height is of the Ferris wheel. As you go around a circle, your height starts raising until you get to the top, and it changes, and it comes back down. And if you were to stay on it, it'd go do it again. So does the function h of t indicate the vertical position of the gondola's pivot point with respect to the axle of the Ferris wheel? Does the function h of t indicate the vertical position? We can tell the height and or the time. I don't know if it's the vertical position. Well, yeah, because you would know the vertical position of the gondola's pivot point with respect to the axle. Oh, wait. I would say no, it doesn't. With respect to the axle and the pivot point, now I'll ask you to explain why the answer is no. That's funny. So my thought process on that is with respect to the axle of the Ferris wheel. So that's like if you look at a Ferris wheel, you've got your center, whatever. So they're talking about your vertical position with respect to like that part right there, or your pivot point, which would be this point. So we know nothing about that pivot point based on this function. We only know the height. So we only know this value here, this value, this value. We don't know anything about where that value is compared to that center point. So I don't know. That's kind of a weird question, but that's kind of where my thought process is. So there's our real world example. Now it is your turn. So try the check on learning. If you need help with it, I'll have a video for you.